Welcome back to my channel on the series of binomial theorem, and let's check out on this. So we have x plus 1 over x raised to 2. Let's expand this using our ideas on on Pascal triangles and other values. So we have x plus 1 over x raised to 2. So that was x raised to 2, 1 over x raised to 0. Can you see that? And you have what? You have x raised to 1 over x raised to 1. Can you see? You can see I decrease this by 1, I increase the power of this by 1. But this is a term, this is another term. Plus x, 1 over x raised to 2, x raised to 0. So you can see how and what I'm using the values. But now what will be the coefficient of this here? And by using my Pascal triangle, I have P2. P2 is what? P2 is 1, 2, and 1. You can see I have what? 1, 2, and 1. 1, 2, and 1 will be what? I have a 1, I have a 2 here, and I have a 1 here. Can you see that? So now, from there, we now know this is what? What is something raised to 0? Note, 1 over x raised to 0 is equals to what? Is equals to 1. Is equals to 1. So that means this is equals to 1. That means I have here 1 times 1 is 1, and I have 1 now equals x squared. What about here? I have 2x. This is raised to 1, this is x, and you have a what? A 1 over x. Can you see that? And last one will be what? Last one will be 1 times 1 is 1, and you have a 1 over x all raised to 2. Can you see that? Then you can try to finish it off by saying, okay, this cancel this. So that is what? As an x squared. 2 times 1 is a 2. And you have a what? You have a 1 over x raised to 2. So you can see this is an expansion of what? Of x plus 1 over x all raised to 2. That is the power of what? That is the power of using Pascal triangle coefficients and what? And decreasing the number of terms. Good. Let's check out some other examples. Clean this up. I would like you guys to check out my video on Pascal triangle. So I'm using the values of the coefficient of Pascal triangles. Then let's take an example. Let's take another question. So let's assume I have square root of x plus 1 over x squared raised to 3. Let's take it out. Square root of x is 1 over x squared all raised to 3. How do we expand that? Very good. We start with this. First of all, note this. What is square root? Square root of x. Note, square root of x is what? L raised to half. That's what square root of x is. X raised to half. And that means you have x raised to half plus. You can write this as x raised to minus 2 all raised to 3. You can take it like that. You can see minus 2 all raised to 3. Doesn't mean anything. Then from there you can say, okay, that is what? X raised to half all raised to 3. Can you see that? And next one now be what? Now be x raised to minus 2 all raised to 0. Can you see that? Next part will be what? Next part will be x raised to half. You decrease the power by 1. You increase it by 1. So the x raised to minus 2 all raised to 1. Can you see that? Next one you have a what? An x raised to half all raised to 1 minus 2 all raised to 2. Can you see that? And the last one is what? X raised to half all raised to 0 and what? And x raised to minus 2 all raised to 3. You can see 3, 0, 2, 1. This comes down, this goes up like that, and you have 3. Now what will be the values here? The values here are very simple from what? You can check that from the Pascal triangle coefficient. The Pascal triangle, the powers of 3, and this is 3 is what? Is 1, 3, 3 and 1. 1, 3, 3 and 1. Then you can fill it up. Here it will be 1, it will be 3, 3, and this is what? And this is 1. Good. So from there, we can try to what? Use the power of lots of what? Of exponents in indices to get this. This is 3 times half. That's 3 over 2. So you have an x raised to power 3 over 2 here. This is raised to power 0. Anything raised to power 0 is 1. Note. X raised to power minus 2 to power 0 equals to 1. So that means this is 1 times 1, that is 1, times all of this, and this is this. Next part, you have 3. You have in 2 multiplies half. 2 times half. You have a 1. So this is 2 times half is what? X is per 1. 1 times minus 2 is what? Is minus 2. So let me put this, they are multiplying each other. Minus 2. Can you see that? Next one, you have a 1. You have a 3. X is per half. Half times 1 is what? Is half. 2 times minus 2 is what? Is minus 4. Can you see it's a minus 4 because it is 2 times minus, that is minus 4. And the last one, this is what? This is 1 because this is raised to power 0. That is 1 times 1, that is 1. And you have what? And you have an ordinary x raised to power minus 6 because it's 3 times minus 2. That gives us minus 6. Then from there we have x raised to power 3 over 2 plus 3 x raised to power 1 times x raised to power minus 2. What do we have? We have a what? X raised to power 1 minus 2. X power minus 1. Minus 1. Because this x raised to power 1 times x power minus 2. Then you use the law of exponents. You have what? X, that is 1 minus 2. That is minus 1. Next one you have 3. Here you have x. Here will be half minus 4. X. Half minus 4. Half minus 4 is what? Half minus 4 is minus 3 and half, and that is what? Minus 7 over 2. So that is minus 7 over 2. Minus 7 over 2, and you have what? X is power minus 6. So that has to what? And have to check out on the what? On the expansion of binomials like this. You can see. So you can try any kind of questions. You just try to what? Use the exact order, then you get your correct answer. So let's take an example on something else. So let's check this. Find. Okay. Number 3. Expand. Expand 1 plus x raised to power 4. Raised to power 4. Let's do that. How do you do this? Very easy. That will be what? 1 raised to power 4. 1 over x raised to power 0. But before you do that, if you can try to write this as what? As x raised to power minus 1. Are you getting? So raised to power what? Raised to power 4. That makes more sense. Then you can say, okay, so this is what? 1 raised to power 4. X minus 1 raised to power 0. Can you see that? Next one you have a what? You have a 1 raised to power 3, x minus 1 raised to power 1. Next one will be what? 1 raised to power 2, x minus 1 raised to power 2. Can you see? And the last one will be 1 raised to power 1, x minus 1 raised to power 1. Last one is 1 raised to power 0, and x minus 1 raised to power 4. So how do you do that? Now, what will be the coefficients here, and here? For Pascal triangle of the fourth coefficient, we have 1, 4, 6, 4, and 1. So here is 1, 4, 4, 'So you have a 6 here, you have a 4, you have a what? A 1. Good. So now what do you do here? 1 raised to power 4 is 1 times 1 is 1. This is raised to power 0 is 1. Everything here becomes 1 times 1 is 1. Next one here you have 1 as 1. Then you have what? You have 4 x raised to power minus 1. Can you see that? Next one you have 1 raised to power 2 is 1 times 6 is 6. 6. But here you have what? 2 times minus 1, that's minus 2. So you have 6x raised to power minus 2. Can you see that? Because you have power of 2 times minus 1 is what? Is minus 2. Yeah, you have minus 1. So you have a 4 x raised to power minus 1. And the last one will be what? This is 1 and 1, this is minus 4. So you have an x raised to power minus 4. So that will be the expansion of this. 1 plus 1 over x all raised to power 4. So there are many ways you can expand. Just use the right procedure. With increasing the values, with decreasing the values, then put the coefficient of Pascal triangles and you have your answer. Thank you. And I'd like you guys to subscribe to my channel because I need more subscribers. So I'd like you guys to subscribe and like and share to your friends. Thank you.